It's 100% something going on. And Petrie, back in the late 1800s, was scratching his head looking at this stuff, and he goes, there must have been a weight of 2 or 3 tons on one. Like he sort of said it was a jeweled tube of bronze that did this. But he was looking at it. He knew a mystery when he saw it, and he couldn't explain it.
What's the speculation? Like, what's the wildest speculation as to how these things were made?
Well, I'm pretty convinced that there was. There's obviously saws and tube drills that are powered by something. Now, I think it may not just be pure friction. There might be ultrasonics involved. One of the whole interesting things I like about this space is it's like, and this has to do with even like the energy stuff that Randall was talking about that he's coming to talk about as well. There are realms of science that sit outside of our understanding. We'll know more tomorrow, in 10 years, in 1,000 years about science. So I think when we look at some of these things in the past, we should be open-minded enough to consider the possibility that some of the answers may sit outside of our current perspective, because our tendency is to look at it all and try and how would we do it?
Right.
How would
does
our
anybody
technology solve
have
this?
wild speculation that you've entertained?
Yeah, I think there's So one of the topics that often gets mentioned here is like ultrasonic drilling. So having it resonate at a frequency that matches the native frequency of the rock and sort of separating the rock more easily. And that's a technology that we're developing. Like, we do some ultrasonic drilling like this today with jewelry and stuff, and you literally vibrate. You find the correct vibration. You can put like a little star-shaped bit through a stone. They do it in like small work. I've seen lots of examples. And if you turn off the machine, it's like Excalibur stuck in the stone. You can't get that thing out. Like, you need that vibration to go through it. Plasma, you can even go as far as, well, they were softening the stone somehow with some molecular technology. Speculation like that. I would also say that some of these examples of technology and machining extend way up to these massive objects. Like, you have 1,000-ton single-piece objects that also exhibit some of these signs of precision engineering. So you might be talking about some truly giant machines that made them. Giant columns and statues and things like that.
And what do conventional archaeologists say when they're confronted by all of this data, the pottery, or excuse me, the vases, this stuff that you're looking at here? What do they say?
Well, you either just get a denial and they won't address it, and you get dismissed as just being ridiculous pseudo archaeology, fantasy theory type thing, or in the case of the tube drills, for example, they will, and it's a funny story, because they will argue that, no, it's not spiral. The grooves on that thing aren't spiral. And in fact, in the textbook, this is what Chris Dunn found out. In the textbook where they do try to address the engineering with that tube drill, they took the photo of the tube drill and they just tilted it, just a little bit. So when you look at it on the page, the lines look horizontal. It's literally in the textbook.
Oh, they fucked with it in the textbook?
Yeah.
Why would they do that?
They altered the photo because if you admit that tube has a spiral groove on it, now you're admitting that they're cutting into that granite at a ridiculous rate, and you can't do any of that stuff with any of the primitive tools. It has this flow-on effect that just knocks over this house of cards that says all this stuff was built with primitive technology, and our whole concept of the ancient Egyptians is off. Now, I don't think it's... I think the dynastic Egyptians, they used primitive tools. I think they just inherited a lot of stuff that's potentially a lot older. And the proof's in the puddings with these vases, for example. That stuff, those things disappear from dynastic Egypt after the 3rd, 4th dynasty. They don't make them anymore. They make alabaster vases.
Is that a tool?
What is that?
That's a fantastic example of what I would call an out-of-place artifact. It's a hollow tube of lapis lazuli, which, by the way, there's no quarries for lapis in Egypt. The closest one's probably in Afghanistan. Came from Gebel Tariq, found in a pre-dynastic site. It's hollowed. It's perfectly made. This is a very difficult thing to achieve, even with modern machinery. And it's displayed in a cabinet next to what? Bone and beads. Right?
And what is that? What is that supposed to be? That tube?
It's something decorative, I assume. It has a gold sheath, but it's a hollow tube. I actually have pictures of it from the end on, not probably in the ones you have, Jamie, but yeah, hollow tube. It's an out-of-place artifact. Like these things from hard stone, and these are more examples. Rock crystal, obsidian gourds and vases that show just perfect, just very high degrees of sophistication.
You should mention the
pre-dynastic,
the statue faces and symmetry. How can you possibly do that by hand? This will wow you.
Yeah. So there's there's a whole category of aspects to the discussion around ancient technology, right? And I have to be kind of careful about what you say, oh, it is or it isn't, because in reality, we really haven't analysed that many artifacts. This vase work that we've done, first one we've actually taken a look at, that core, that's the first one and the only one that's really been analysed. So I characterise something that's beyond the capabilities of these primitive ancient civilizations as being, okay, machining marks, tool marks, like these giant circular saws, tube drills, precision, and there's elements to precision, and one of those is symmetry. And there's been some interesting studies done on the faces of giant statues. One in particular is the face of Ramses. There's a statue at Luxor. They've since put the head back up. It's up now 30 feet in the air on top of the statue, but it used to be on the ground. And again, Chris Dunn was real seminal in this. He went and took a photo, like bang on, like very front on, and then what he did was you take a copy of that photo, you make it 50% transparent, make the original 50% transparent, you take one and you flip it like on that horizontal axis, then you overlay them, right? So you would see like the left to right, it's like overlaying the left side on the right side, and it's perfect. It's this face here, but I wonder if you can find the picture of Chris Dunn. That's actually
there's your video right there.
Videos there as well, where I get into it.
Website, but that's not that picture you're asking for.
No, it's similar, but it shows other aspects of, well, the same radius of tool being used to cut. But what's interesting about the symmetry, it's perfectly symmetrical, left to right. Now, this isn't a feature in humans. No human is perfectly symmetrical, different nostrils, different eyeballs. It's also not something that is done in artwork. So, people often say, well, Michelangelo, he carved David. It's a beautiful statue. I've seen it. It's incredible. But it's human. It's not symmetrical. Symmetrical is, you can't achieve that degree of symmetry just by eyeballing it and doing it by hand. And it's also something that's not really human. I think some of these statues almost look a bit inhuman because of that symmetry when they're up there and they're staring at you, because it's mind-blowing to actually go and look at them. But it's the other aspect is the most efficient way to create that would be to say, well, if you were going to design it in a computer, it's like, well, I'm going to create half this face in a program and map it out, and then I'm just going to reverse it and say, well, that's the other half. It's literally the most efficient way to do it, and that's kind of what we're seeing in some of these statues.
Go back to that image, please.
It's virtual perfection.